Shall we set experimental aggregate gradients to false or true when manually accumulating gradients in TensorFlow? I am trying to perform a manual gradient accumulation in TensorFlow 2.2.0 using Python 3.8.5. I have a piece of code where I gather a series of gradients of total number of total number in a list, list, and I do the accumulation using following code. I then intend to apply these grads via my optimizer to my model. Where my optimizer is atom defined as tf.caras.optimizers.atom. However, due to the documentation here, I am confused if I have to set experimental aggregate gradients to false. I could not clearly understand here that I have done the accumulation manually. If I let it be true, it continues to accumulate? Any help is very appreciated.
If you are using distributed strategy, i.e. distributed training across multiple POOs, multiple machines, or TBUS, then experimental aggregate gradients parameter comes into picture. In distributed strategy, the gradients are calculated on each replica, then they are aggregated across the replicas by summing them. Aggregating across the replicas would be taken care by itself if experimental aggregate gradients equals true, else have to be taken care manually if experimental aggregate gradients equals false. It will not make any difference if you set experimental aggregate gradients equals true or false if you are not using the distributed strategy. If you look into documentation of tf.distribute.strategy, you will find the below parameter. num_replicas in sync returns number of replicas over which gradients are aggregated. To summarize, if you are using tf.distribute.strategy and if experimental aggregate gradients equals true, then gradients computed in different replicas are aggregated automatically. If experimental aggregate gradients equals false, then it's user responsibility to aggregate the gradients from the different replicas. By default, the experimental aggregate gradients is set to true. It wouldn't make any difference if true or false unless using tf.distribute.strategy.
If you want to support the channel, please consider liking and subscribing.